Hello again. We're looking at problem number 3 from section 11.1. This is found on page 690 of your textbook. It's talking about verifying Euler is really the better pronunciation. It's formula for two dimensions. Now, in problem 2, which is a previous problem that we put on video, we said that for three dimensionals it was the face plus the vertices equals the edges plus 2. This time, because we're dealing with two-dimensional things, that means if you, like this is two-dimensional, this would be three-dimensional down here. So two-dimensional, three-dimensional. For two-dimensionals, Euler said that it's the faces plus the vertices equals the edges plus 1, rather than the edges plus 2, like we did in the previous problem. Okay. Now, if that is true, let's look here. If you were trying to verify, that just means prove Euler's formula for the net problem, again, you would look at the number of regions. Now, a net is when you unwrap a particular shape, like the one on the front page. You would unwrap it as though you were taking it apart and laying it out flat. And for some people, they really struggle visually with this. But if you could take a problem, I think this was in problem number 2, and you could lay it out flat, you would have a hexagon on top and one on bottom, and then the 6 sides that wrapped around that would be laid out flat. Now, this is not the only way you could have drawn the picture. This is just one example of the picture. Now, once it is laid out flat, if you count the number of faces, then you have, of course, 1, 2, 3, 4, 5, 6, 7, 8. So that's where they're getting 8 here. The number of vertices, again, you would just count. You've got 6 there, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, which is why they have 22 there. And then again, if you wanted to count the edges, you've got 1, 2, 3, 4, 5, 6, 7, 8. Can't double count that one. So 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, which is again why they're getting 29 right there. Now again, remember, because this is two-dimensional, instead of three-dimensional, the formula changed to faces plus vertices equals the edges plus 1, which is what he's written down here. And so 8 plus 22 should equal 29 plus 1, and they do. They both end up equaling 30. Okay, so let's see if we can apply that ourselves. And again, one of the hardest things that most students do is drawing the net, which is the part that's laid out really flat. So it says, how can you verify Euler's formula, which this is the one for when it's already in three-dimensional shape. We use the E plus 2 for the solid. Okay, so if I look carefully at this particular problem, if you count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You're going to have 12 edges, so I'm going to just fill that in for A. And then the number of faces you have a top, you have a bottom, and you have the 4 sides here, which end up making a total of 6 faces. Okay. So I'm going to put a 6 there. And then the number of vertices or corners, you have 4 on top and you have 4 on bottom. So you're going to end up with 8. And so that ends up being 14 equals 12 plus 2, which is also 14. So that verified that that formula does work for a particular solid. Now, if I could take this, and B says to draw the net of the solid, if I could roll these out, I would, let's start with the bottom piece. You would have a square here, and then if I could fold this side outward, it would look like that. And if I could fold this side outward, it would look like that. It would lay flat. And then if I could really unhinge this one and lay it over here, it's a little bit smaller than the other ones. So we're saying that this is the top. Of course, this was the bottom. This would be the left side. This would be the right side. And then you have the two ends. And they make trapezoids. So you would have what I call the back side and the front side. And so you just have to imagine laying that out flat. And when you do, again, when you count these, you're going to have 1, 2, 3, 4, 5, 6 faces. So you're going to have 6 faces. Vertices, you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you're going to end up with 14 vertices. The edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So there's going to be 19 edges. And according to the formula, you add 1. And 6 plus 14 is 20, in the same way that 19 plus 1 is also 20. So we verified it for both two-dimensional and three-dimensional. A was all about the three-dimensional drawing, and C was all about verifying Euler's formula for when we've laid it out in a two-dimensional format or laid it out flat, which is called a net. Hope this was helpful to you. Best of luck.